Okay, this is for question 47, and I'm actually going to state that I'm taking down as being positive in this question. So, what we actually have is for A, we actually want to state our value of change in momentum is equal to mass times the change in velocity, which is equal to 0.060 multiplied by -6.0 minus 8.0. Remember, it's my change in velocity, so -6 subtracting the 8, which is equal to negative 0.84 kilogram meters a second. Or, because I've actually said down as positive, it's 0.84 kilogram meters a second up. But I don't need to state that because of that previous statement. For B, what we can actually find is, or we can just make a statement without much calculation, 0.84 kilogram meters a second. Because that's a positive number, it's actually down, or I can actually say that it's down. The extra information isn't going to hurt us. From there, well, we can actually state that the impulse applied by the tennis ball to the ground is equal and opposite to the impulse applied by the ground to the tennis ball. So there is some extra information that you could add to that with a description. Our next one is C, and we can actually go through and state no. And the reason for that is the ground does not move a measurable amount. So it moves so small that we can't even really measure it. The impulse applied to the ground is 0.84 kilogram meters a second, but the mass of the Earth is so large that it can change in velocity. It's basically negligible and doesn't actually make any difference. Our next one for D actually has a bit of working out for us. So D is actually, if we have a look at it, our net force multiplied by our change in time is equal to our change in momentum. We rearrange that formula and we end up with our net force is equal to the change in momentum over the change in time, which is equal to 0.84 kilogram meters a second, and I'm going to state up here because it is up, all over 2 times 10 to the negative 2, to the negative 3 seconds. So my change in time and my change in momentum, which is equal to 4.2 times 10 to the 2 newtons. And I'm actually going to state that that is also up because of my previous statement at the start. I said that taking down is positive. If I don't make that reference of up, but I've changed the value of it in terms of a positive or negative number, it does change the direction. So you've got to be wary of that. Our final question is E, and inside E we know that my net force is equal to newtons N minus mg, which helps me solve 4.2 times 10 to the 2 from our previous question, just down there, is equal to Newton minus 0.06 multiplied by 10, which is equal to N minus 0.6. Solving that side. We can then transpose that question for N is equal to, let's just start again. N is equal to 4.2 times 10 to the 2 plus 0.6. So that's just transposing, adding 0.6 to both sides. which is equal to 4.2 times 10 squared newtons up. Now, why doesn't it actually make too much of a difference is because we've got this scientific value. If you want to round it and make it more specific, so you do go with 4.2.6 or whatever it comes out to be, you can, but you're also welcome to complete it like that, and that will give you your correct answer. That's the actual answer and solutions for question number 47.